Hey everyone, it's Mr. Gasman here to talk a little bit about what is momentum. So it's probably a term that we've all heard. We've either heard it talking about the sporting event and who has the momentum in a game, or talking about collisions when you run into your little brother or sister. What is momentum? So there's a couple of different examples I have here pulled up that all display different parts of momentum. So our first video down here, we have a little boy learning about momentum. Here for our second one, we've got a curling game going on up in Canada talking about momentum. And then we finally have one more, some looks like middle school football players learning about momentum. So what is momentum? Let's take a look. Momentum is the mass of an object multiplied by its velocity that it's traveling at. So momentum is how big an object is, how much mass, how much matter is in that object, multiplied by how fast it's going, its velocity at that point. So momentum is a lot like inertia, and it does influence, or mass does influence momentum. And then your momentum also will determine an object's resistance to change. A large object will not want to change its motion. And then our momentum equation, P is our symbol for momentum. So our variable for momentum is P. And when we look at P equals mv, it's momentum P is equal to the mass of an object times its velocity. So the greater the mass and the greater the velocity, the larger momentum is going to be. So momentum is measured in kilogram meter times meters per second. All right, mass obviously is measured in kilograms and velocity is measured in meters per second. So momentum is equal to mass of an object multiplied by how fast it's traveling, its velocity. That brings us to conservation of momentum. When two objects interact, and if they're in a system that is not acted on by an outside force or a very large outside force, the total amount of momentum in the system cannot change. What that really means is that objects, when they're moving, if they run into something else or if they hit another object, that the initial momentum has to be equal to the final momentum. If two billiard balls hit each other, the initial momentum before the collision needs to be equal to the momentum after the collision. It's very important that momentum is conserved. So all of that momentum, mass times velocity, right, whatever that value is before the collision, needs to be equal to the momentum after the collision. There's a little more we could go with this, but that's pretty much it. Knowing that momentum is mass times velocity for an object, and that momentum before a collision is going to be equal to the momentum after a collision is really where we need to be and really what we need to understand. So if you have any questions, please reach out to Mr. Swenson, Mr. Oleg, or myself. Have a great day, everybody.